guys, in this unit we are going to be covering waves. So what examples come to your mind when you think of waves? What do you think water waves, microwaves, sound waves, and radio waves have in common with each other? These and all other types of waves transfer energy from one place to another. In this lesson we're going to be talking about the characteristics of waves. Water waves are probably the easiest type of wave to visualize. If you've been on a boat on a lake, you know that approaching waves bump against the boat but do not carry the boat along with them as they pass. The boat mostly moves up and down as the waves pass by. Only energy carried by the waves moves forward. Waves are rhythmic disturbances that carry energy through matter or space. Water waves transfer energy through water. Earthquakes transfer energy in powerful shock waves that travel through the earth. Both types of wave travel through a medium. A medium is a material that wave energy travels through. So there are two types of waves, and the first type of waves we're going to talk about are the transverse waves. So here's an example of a transverse wave. The line through the middle of the transverse wave is known as the resting point. From the resting point to the bottom of the wave and from the resting point to the top of the wave is called the amplitude. To measure wavelength of a wave, we measure it from the top of one wave to the top of the other wave. You can also measure this across the bottom. The highest point of the wave is called the crest, and the lowest point of the wave is called the trough. Wave frequency is the number of wave crests that pass through one place each second. It's measured in hertz, or Hz. So here are two examples of waves. The first is a wave that has a very short wavelength. The second wave has a very long wavelength. So frequency increases as the wavelength decreases. This means that the wave on the top that has a shorter wavelength has a higher frequency than the wave on the bottom. So, sometimes you may want to know how fast a wave is traveling. For example, earthquakes below the ocean can produce giant tidal waves. You would want to know how soon the tidal wave would reach you if you needed to seek shelter. Wave velocity describes how fast the wave moves forward. The formula for this is velocity is equal to frequency times wavelength, or V is equal to F times lambda. Wave velocity can be determined by multiplying wavelength times frequency. For example, a wave is generated in a wave pool at the Great Wolf Lodge. The wavelength is 3.2 meters, and the frequency is 0.60 hertz. What is the velocity of the wave? So first we need to know that our wavelength, or lambda, is equal to 3.2 meters. Second, we need to know that our frequency is 0.60 hertz. So again, our formula is V is equal to lambda times F. This needs to go in your formula sheet. Once we plug those in, V is going to be equal to 3.2 times 0.60, and our answer is going to be 1.92 meters per second.